In the race to take autonomous cars mainstream, sensors can only get you so far. At Hitachi R&D, software research engineers are hard at work developing an artificial intelligence system unlike any other. One that makes autonomous cars more human. The jerky, robotic nature of many autonomous vehicles is one of the major hurdles to widespread adoption.
Think about it. Nobody is going to be comfortable sitting in a car that accelerates or brakes too sharply, or that handles corners too sharply.
An autonomous ride needs to be just as smooth and safe as a journey in a chauffeur-driven vehicle. Hitachi's solution? Get humans to teach autonomous vehicles how to handle the road. While the eyes and ears of autonomous vehicles are crucial to perceive the surrounding environment, Hitachi has also been busy building the brains. Here's how its AI system works. First, the team collected data from a wide variety of human drivers, with the purpose of capturing the underlying human driving characteristics. This provided the engineers with massive volumes of data on how human drivers handle almost any situation on the road. This human data was then fed into Hitachi's data science and machine learning pipeline, specialized for autonomous vehicles. Hitachi's neural network was trained to understand the flexibility that separates human drivers from machines, and, as a result, make better decisions than any human or machine. Take accelerating, for example. In one situation, a human driver might decide it is safer and more appropriate to accelerate rapidly. In another, a more gradual acceleration might be necessary.
For an AI to learn this, it needs to understand exactly why human drivers make certain decisions in certain situations.
With this process understood, the AI can then augment its new knowledge from data collected from other sensors and inputs to give it an advantage over a human driver. To gain that advantage, the AI system relies on another crucial component: simulated data. While humans mostly learn from what they directly experience, an AI can learn from simulated experience that, to its understanding, are identical to the real thing.
In practice, this means Hitachi's software engineers can simulate any scenario on the road, and the AI will respond and learn from it as if it were real. This means an AI can, for example, learn time and time again what happens when it, or someone else on the road, runs a red light. This gives the AI the ability to experience more in mere minutes than a human driver might in an entire lifetime. Lessons learned, the next part of the AI puzzle, is not just ensuring an AI is making the right decisions, but also understanding exactly why those decisions are being made.
To help with accountability, Hitachi's AI is also modular, which makes it easier for software engineers to pop the hood and see what's going on inside. Each of the AI's 4 modules is responsible for a different part of the decision-making process. The first manages perception based on data from sensors. The second uses localization data and other sensor data to help the car understand where it is. Next is a module that understands the route. And finally, there is a module that controls the car. This modular approach helps software engineers break down any problem the AI encounters and turn it into a series of smaller problems. This works in a similar way to your own brain. Your failure to spot a crucial road sign, for example, might be because the sign was poorly located, or because you were distracted by a sudden noise or bump in the road.
For an AI, this modular design allows software engineers to understand exactly why a certain decision was made and, if it was the wrong decision, ensure it doesn't happen again. To do this, each module of the AI system operates within a series of engineering margins to protect against any errors the AI might make. Just like with human drivers, each module needs to expand and contract its limits accordingly.
Don't spot a red light early enough. That's a failure of perception. To counter this, You rely on your reaction times to hit the brakes harder than normal, but still safely enough so as not to cause an accident.
The same goes for an AI. When one system falters, another can adjust accordingly to make the right and safest decision.
It's not about teaching an AI to drive like a human, but taking the best parts from human drivers and using this data to create a smarter, more flexible AI. Coupled with software engineering rigor, Hitachi is using human thinking to solve major problems in the driverless car process, one data point at a time.